Good morning and welcome everybody. Now we are going to discuss about distance and displacement and their differences. So let us start with a simple example. For example, you are at some position at a time. Let us name it this position A, and you move somewhere around and you reach at the position B. So when you move from A to B, you cover some path. So the total length of the path you traveled is called distance. Total length of the path is called distance. So whenever we are concerned with the distance, we have to find how much path we traveled, how much length of the path we covered. You move from this to this. Let's say you traveled for 90 meters to reach to B. If from the same position another of your friend moves like this and he reaches at the position B by covering 110 meters, so his distance is 110 meters even though the points were same. But there is a third one that starts his journey from here and he directly moves to the point B from A to B. So he has the shortest one and it might be, let's say, 70 meters. So he just directly moved from position A to position B, the initial position A to final position B. So this is also a distance, but this one is the shortest one, that it is directed toward a specific direction. So this one, the shortest one, is a distance, but this shortest distance is a directed one. He is not moving here and there. So this shortest distance is named as displacement in physics. Shortest distance is called displacement. So this displacement can also be defined in another way, that it is a change in position with respect to some reference point, or it is relative to some position, that is called original position or reference position. So change in position is also called the displacement. So here, if you are taking your measurement with some reference point, the position of point A with that reference point, let's say this is the tree and this tree is the reference point. According to this reference point, the position of A with this reference point is, let's say I say this is 30 meters from this reference position, and position of B from this reference point is, let's say, 100 meters. So what will be the displacement from A to B? So I will find the change in position. So this man or you or someone was at 30 meters from the tree initially. Now he is 100 meters from the tree. So what you will do, you will say is displacement is displacement is 100 meter minus 70 meters. Sorry, minus 30 meters. So as a whole, the displacement is 70 meters. So now what we found here is that very important thing we need to remember when we say that it is a distance. So it is the total path we covered. But when we are talking about displacement, we need to focus direct from one position to another, from initial position to a final position. So I can say that in my own way, that if we denote that the displacement is denoted by, let's say, delta x. So this small triangle is a Greek letter delta. That will be the final position x2 minus initial position x1. This x2 is the final position with reference of this tree, and x1 is the initial position with reference of this tree. So delta x is the change in position which we use as a displacement. So change in position, and this I told you, this symbol is called delta, and it is a grid, and it means that change in, we use it as for changing. So now if we are going to find the differences between these two, what we call these two physical quantities, distance and displacement. So we can easily say that the distance is something or some physical quantity that require only the magnitude, but it doesn't need any direction. It does not need any value. It need value but no direction. So we can say that distance is a scalar quantity. So it is a scalar quantity as compared to the uh, displacement. So on the other hand, when we are concerned with the displacement, so we can say that the displacement is a vector quantity. It is a vector quantity. So this is a vector quantity. On the other hand, it has unit. SI unit is meter. We can also use kilometer and feet or inches by using your conversion factors. And for the distance, it is also having a unit of meter. So to have more understanding, let us see any other example for more understanding. For example, we have something that we can say, if there is any question in my point, yeah, if we talk about the question is, we have someone is moving to the east for 70 meters, and then he gets back 30 meters. So total distance traveled will be 70 plus 30, that is 100 meters. But when we are talking about the displacement, so displacement need to be checked. What is initial position and what is the final position? When we have initial position and final position, then we can check what is. So initial position from the point where we are, it's called the reference point, and final position is with respect to the reference point. Let me give you a complete understanding by this example. We have this example that is written question number 32. So in question number 32, it is said, if a person walking 123 meter to east and then returning and then turn around and walks back west, a distance of 27 meters. So he is actually moving in one direction and then getting back to the other direction. Let me start with the, for example, it is the original position. The man goes from here to here. The position, let's say it was A position and 123 meter from A to B, and then moves back to the west direction, and in this direction he covers 27 meter and reaches at some point C. So whenever we are asked to find the distance, so we don't need to worry about anything. We need to find total length of the path traveled. So total length of the path is 123 meter plus 27 meters. So that gives us 150 meter regardless of any direction. So our considered answer is 150 meters. So we don't need to talk about the